This is my BMW Series 3 E46 330xi. It's a 2001 model. In the past, I've stored this vehicle in a three-sided shed without any doors. This is a hobby car that gets driven maybe only once or twice a week, and just to keep the battery up, but it's not my daily driver by any means. This summer, I took the BMW out for exercise drive, and during that drive I noticed that the speedometer was not working. Also, the anti-lock brake lights were on, and at the time I was kind of busy with some other projects, and I just parked the car, and it's been 2 or 3 months before I got back to it to try to investigate what was going on. I moved the car into my shop, and I found that some critters apparently had been at work on the wiring, probably squirrels. They'd chewed the cables leading to the rear wheel sensors. In addition, the fuel line had been chewed, and there was some gasoline dribbling there. I also noticed that the outdoor air temperature sensor was reading a -40 on a nice warm fall day, so there was definitely some kind of a problem. I started the repair with the outdoor temperature sensor. Let's take a quick look at that sensor and move on from there. As you can see, we're now looking at this would be the driver's side of the vehicle, and my hand is on the left front wheel. This is the air temperature sensor, and there is a flat area above this, and between the wheel weld, which goes up behind here, there's a nice flat area. Apparently the squirrel decided to crawl up into the engine compartment, then comes down and decided this would be a nice place to build a nest, and promptly encountered the wire going to this sensor and decided it was in the way. It snipped it off. Now, if you've dealt with squirrels before, you know that one of the nasty things about their work is that they like to go right up to the connector, snip the wire off almost like you use a pair of side cutters right at the connector. So first thing I had to do is go to the salvage yard, get a new connector, and then splice the cables. I put those back together after removing the fender liner here behind this area, and everything began to work okay. The display on the dash showed what appeared to be an accurate outdoor temperature. So far, so good. Okay, having gotten the temperature sensor up in the front of the car repaired, let's go to the rear. And obviously I'm at the passenger side, right rear of the car. And first, let's take a look at where the speed sensors are located, and then I'm going to attempt to describe the damage that was done to the sensor system. You're looking now at the right, that'd be the passenger side rear wheel hub, and on the left of the image, as you see at the present time, is the disc pad assembly. And if you move around here, you can see a cable coming into the disc pad assembly. Now that cable is just my finger is on the cable right now, and it's a little button that goes into the pads and just indicates if you get enough pad wear, it breaks the circuit contained in this cable and sends you a trouble indication in your panel that you have brake issues if the pads get too thin. Now then, let's see if we can get a look at the actual speed sensor on this right rear hub. The camera in a wheel well, and this will give you, this is actually near the center of the photo here is the actual speed sensor. Probe here is actually resting right on the sensor. It's held in place with a single bolt, and the sensor goes down into an opening here, and as the wheel rotates, there is a slotted assembly underneath it that changes the magnetic field and causes a count of the wheel speed. This is a wheel sensor, a new one that I haven't that I ordered just to have on hand in case I needed it. Has not as yet been used, but anyway, the anchor bolt goes through this hole here, and then this stub sticks through, and a slotted wheel moves underneath this to change the magnetic field that's picked up by the sensor. Now the wear sensor, the little part that goes into the disc pads, is just a little button like so, and this slides into a slot in the disc pads. As this little bud wears away, it'll break contact inside, and when it opens up the loop, why, it sends a signal to the instrument panel telling you that you're supposedly indicating that your brake pads are thin and need to be replaced. Now we're under the car, and again we're looking at the passenger side, the right side of the car, and the camera is more or less on the hub of the brake assembly here. And as we move forward, we can see the cable. My pointer is kind of falling. It's pretty hard to see here in this light. And there are two cables involved again. One is the speed sensor, and the other is the wear sensor. We go on forward, keep moving forward, and we get to the place where little critters did their dangerous job. And right here you see this is plastic thing that's being held together with a piece of wire now because it's all chewed up. But inside here are two connectors, one for the speed sensor and one for the wear sensor. And the wire comes up out of the top of the box and goes into a rubber grommet. And I've got the end of this pointer just on the rubber grommet. This is where it goes into the body of the car. And of course, they got a hold of the wires right at that rubber grommet, chewed them in two. It's too short to splice it, and so had to go to the salvage yards and get the female, I believe it is, female end of both connectors. And right here you notice that this is the wear sensor, again, cable. It was spliced here. They chewed that in two, but miraculously, for some reason, they didn't decide to chew the speed sensor in two. So now let's go over to the driver's side, or the left side of the vehicle. Now in this case, I've opened the splice box, the little box here, and the actual splice, the cable splice, where it goes from the speed sensor to the I guess this would be the body connector. Goes through this, and normally that's inside the box, but I've just dropped it down here for video purposes. And then again, it goes through a rubber grommet just like it did on the right side. And again, the squirrels chewed it off, destroyed this connector. And right here, they also chewed, in this case, they chewed the cable for the speed sensor. And you can see the jumpers I put in here. I wanted to make sure I had continuity through this connector here. And that's the reason for the jumper wires on this. That's it. To gain access to the wiring harness inside the car, I removed the rear seat cushion. And as you look through the rear passenger door into the car at the moment, you can see the cushion has been removed. I also pulled forward the some of the carpeting material that goes right around the front of the seat. So if we look right here, we can see, first of all, this is the wiring as it was stubbed through the body of the car into the passenger compartment. I pulled out the old wiring that had been chewed by the critters, and then this twisted pair here, the blue and brown wires, are the speed sensor. Now again, we're on the left side of the car, so we don't have to worry about a wear sensor on this side. It's only located on the right side of the car. So basically I accessed the wire and I added these stubs tying the wires together. And so this was also a very similar situation on the right side, again inside the car. Stubbed the wires through and reconnected them. So now I have the speed sensors reconnected with and used some sockets that were obtained from the salvage yard for the ones that were damaged by the critters. So now it's ready for a test drive. Well, the test drive just really didn't go very well. There was the indicator lamp for brake pad wear did go out from the dash, so that was good. I suppose that was a slight improvement. However, all the other ABS lights and idiot lights in the dash remained on, and even after driving, I was hoping they'd reset themselves after a few miles if everything was talking all right, but it didn't. So, and my speedometer still didn't work. So I thought, well, I know that the squirrels had gotten into this engine compartment. Perhaps they chewed some of the wires, and on this would be the right side of the vehicle, right in front of the glove box in the engine compartment. I'm looking down now into the control module for the ABS system, and you can see the hydraulic lines here. I tried to very carefully check the wiring and examined it to see if some critter had been chewing the wiring, but it very quickly goes into the body of inside the body of the car. And I was pretty sure that no squirrels had gotten inside the car. So again, I was looking for broken wires. Maybe somewhere, somehow, a squirrel had chewed a wire into, and it was still, the sensors still were not communicating with the ABS module. As the part of getting more serious about this, began to drag out my code reader, and I had a nice unit here that, as I recall, is not terribly expensive, and it had the Bosch name on it, comes out with a display, and I've had this for a number of years around the shop here, just for my do-it-yourself projects, and it's worked pretty well, and it's intended to work with a variety of cars, including the BMW. But when I tried to get into the ABS codes, at one point it came up and said something about was not communicating with the ABS module. So I dug around in my box of code readers, and I came up with a second code reader. Excuse me. With a second code reader. Don't really remember the history of this, but it does call it a BMW scanner, and it looks like this one works with a piece of software in my laptop computer. Plug it in, and then the data is displayed on the computer as a display screen. This works pretty well. As I recall, it's not terribly expensive. It's probably a Chinese-made product. I don't know, but anyway, it did access the ABS module, and it came back and it said that the ABS module was temporarily shut down. Yeah, that was kind of alarming. It also said that the left rear and the right rear speed sensors circuit was open. Well, I was pretty sure that wasn't true, because, you know, I checked the continuity through my connectors, and I was really sure that I had made electrical contact, but they certainly weren't working. And then the issue became up, well, what about this ABS module being temporarily shut down? So I tried through this code reader to clear the error codes, and after a number of tries, finally the error code which indicated that the module was temporarily shut down disappeared. So hey, there was some progress here. But the left rear and left right circuits were still showing error codes as not being connected. What you see in front of the camera right now is the cable assembly and a speed sensor. The speed sensor is here. My pointer's looking at it, and this came from a salvage yard because I was needing these connectors here, kind of in the lower part of the viewing area, and obviously this is for the right side of the car, the passenger side, because this connector, the female portion of it, is missing, but this connector is for the wear sensor, and this connector is for the speed sensor. And this is the assembly where it is plugged in or disconnected if you're replacing a sensor. And of course I also needed, because the squirrels had chewed off the cable connection about right here, just before this grommet, so I also needed this replacement piece of wire right in here that was that had been damaged by the critters. And the two wires here are for the speed sensor, and the twisted pair here is for the speed sensor, and the two wires here are for the wear sensor. Now, I went on the internet and did a little research, not knowing too much about the technical part of the speed sensor. All I know is I must have done something wrong, that the system was still not working. And I found basically there are two types of speed sensors. There is the passive sensor, which is basically a permanent magnet located here in the head, has just a coil of wire around it. And there is a slotted wheel that rotates in front of the pickup, and the magnetic field is changed as the slotted part of it rotates with the wheel, and this becomes a little generator, a little AC generator, and the signal is sent back to the ABS module so that it can decode the frequency of this little AC voltage, and obviously that frequency would go up as the speed goes up. So that's a very simple thing, a permanent magnet here, a coil of wire wrapped around it, and it becomes a little generator. The second type is an active type, and it actually has an electronic component, some sort of a field effect transistor inside here, and a magnetic field changes slightly, it triggers, and you have an electronic device switching the signal on and off, and it produces more of a square wave. Apparently, I am told that this type of sensor is better because the output voltage of it doesn't go up and down with speed, and sometimes at real low speeds the non-active type, the passive type, has the controller has a little trouble detecting the signal at really low speeds. So the question is, what type of sensor do I have? Well, really all I need to do is connect an ohm meter onto it. If it's a coil of wire, what would you expect? Well, you would expect maybe 100 ohms, or at most 1,000 or 2 ohms of resistance. You could also reverse the polarity on the leads, and it shouldn't make any difference. However, if it's an active type with an electronic component in here, well, who knows exactly what the reaction of an ohm meter is going to be, but it's not going to react. The ohm meter is not going to react the same way it would if it were just a coil of wire on a permanent magnet. Now, my first thoughts were that, okay, if this is the passive type with a permanent magnet and a coil of wire, as I mentioned, the ohm meter would be a nice way to check it, but I should be able just to hold a piece of steel, let's say something like this up here, to the face of it, and I could not feel any kind of a magnetic field associated as I passed this over it. It didn't seem to be attracting the piece of steel. So immediately I began to sway my opinion toward the active type. However, when I took an ordinary compass and moved it first toward the head of it, you can see that the south-seeking, hopefully I've got this so you can see the south-seeking part of the compass swings toward the tip. But as I just move downward, the north-seeking end of the compass swings through. So whether this is an active or a passive type unit is not clearly indicated here, because it appears that it definitely does have some type of a magnet inside. So let's move on and try the test with an ohm meter. So now I've got a multimeter laying here, and it's set for full scale here of 20 mega ohms, very high resistance. And I'm using alligator clips rather than just holding the leads to the wires, because at this high impedance you run some risk of measuring the resistance through your skin, and so I wanted to eliminate that, so I'm using alligator clips to the clips on my multimeter, and that reads 12.56 right at the moment, and that's mega ohms, millions of ohms, 12 million ohms, 13 million ohms, very high resistance. Certainly not what I would expect, assuming this pickup coil hasn't got a broken wire in it. It's certainly much higher than I would expect for a passive system with just a coil of wire here in the head of the unit. So as a further test, let's reverse the leads, because if it's an electronic component in there, the resistance may be different. And you notice the one indicates it's an open circuit. So when I reversed the probes, then I get an open circuit indication in my multimeter. So I certainly am leaning toward the fact that this is probably a active type sensor. In fact, if I touch the two together here just to double check, so the meter does swing to 0. When I pull this back open again, it swings back out. I don't know if I put my hand across here, it may yeah, there's 8 million ohms, which is just the resistance through my skin. So that's another reason to use alligator clips, so that you don't measure your skin resistance. But obviously when it's hooked one way, you get an open circuit. And when you hook it the other way, let's see what we get this time. Well, it looks like, yeah, it's going to go back to around 12 million ohms. So I believe that I have an active type sensor. Now this sensor did not come out of my car. It was taken from a salvage vehicle, but it was about the same time frame, vintage as mine. It looks very similar. And when I actually did this same test on the sensors in the vehicle, I got a similar sort of result. Now, I need to mention here that I have also, in the process, this went on for a week or, well, probably for a month or two, just tinkering with this car. I'd come in and work an hour or two and get frustrated and then go do something else. I went ahead and ordered some new speed sensors, and when I put those in, let's see if I can hook this one in. Now the polarity hasn't been changed, but on the brand new sensor, I get an open circuit, and it doesn't matter whether the leads of the meter are reversed or not. I just mentioned this to you if you're working on this, that you can get some results that and I don't know why this is the case. My guess is that the electronic component in the head ages, perhaps they get a little leaky, and you do get, as you saw in this particular one, about 12 million ohms, and perhaps as time passes, these begin to deteriorate and get lower and lower resistance. But I suppose the other possibility is that the new speed sensors are defective. I hope that's not the case. I have not tried to use them. Having done this research, knowing that I probably have an active type sensor, the one thing that you would think that will happen is when I have this hooked up, I'll need to have a source of voltage to the electronics, so that the ABS unit should be sending a voltage to the electronics inside this pickup head to power up the I guess we call this probably some sort of a field effect transistor inside here, and it has to have an active source of power running to it. So I hooked a voltmeter up to my the wires coming out of to the sensor, and when I turned the ignition on, I saw nothing. I tried this several times, nothing. So I became kind of concerned that maybe the critters had gotten into the engine compartment and chewed the wires up there, or somewhere else that actually the ABS module was not able to communicate because of an open wire somewhere. I spent some time hunting for this and could not really find any indication of additional wiring damage. So I decided to pull out an oscilloscope and thought perhaps the signal going to the speed sensor might be some sort of a digital analog signal that I just couldn't see on my voltmeter. So what you're going to see is what happens when I hook a oscilloscope up to the wiring. Okay, now I've got a spare speed sensor just lying in the back seat of the car. I've got the scope going, and again it's scanning horizontally. It's scanning there about 1 second per division, and each vertical division on there is about 5 volts. So let's turn the ignition on and see what happens. Okay, here goes the ignition on. Switching the ignition off. Now switching the ignition back on. Now this looks good because it appears that the ABS controller is sending a voltage to the sensor. However, after a couple of seconds or so, it just collapses. So now let's turn the ignition key on and see what happens. Okay, notice that I have reversed the polarity on the wires, and it's about 2 divisions, 10 or 12 volts there. It's come up, and it's staying up. And okay, now I am waving in front of it a pickup tool that has a magnet in it, and you can see that as I take it back and forth, it's showing up on the oscilloscope 3 or 4 volts, waving back and forth as I bring it back and forth. Now This pickup that I have in my hand is an extra one that I picked up out of the salvage yard. And what's different from this time as compared to the first test that I did was all I did was reverse the polarity of the wires leading to the pickup. So lo and behold, this is good because first of all, since the voltage is offset about 10 or 12 volts, I know that the controller for the ABS system is sending voltage to this pickup head, and when I see the scope giving me these little blips, it means that the electronic device inside is responding to my magnet and talking to the ABS controller. Now I have the scope back up running again, and I've connected the speed sensor. I'm looking at the left rear tire, left rear wheel sensor, and I've got the ignition switch on. You can see that there's about a 10 or 12 volt offset, and with the rear wheel raised, let's see what the signal looks like if I rotate the tire. Take me just a second here. Okay. As you see, I get a little swiggle every time the slot goes by the sensor. So the sensor is definitely talking to the ABS controller, and as soon as I stop rotating the wheel, it goes back solid. Now we have gotten to the point that I've discovered that I have active type speed sensors. I've discovered that polarity is critical, and apparently I had gotten the polarity reversed, not on just the one side, but actually both sides. Actually, on the right side, the wiring harness inside the body of the car, there's no color coding. So, you know, if you make a mistake there and you have to put a new connector onto that, getting it backward is perhaps not such a big deal. However, on the left side, the driver's side, the color coding of the wiring harness inside the body of the car is color coded. But unfortunately, the squirrels had chewed the cable underneath the car in two on the speed sensor itself, and when I reconnected those wires, they were not color coded. So again, I got it backwards. You know, the old deal, if there's a 50% chance of getting it wrong, it'll be 98% chance you'll get it wrong not only once but twice. So trying to reduce the story length some bit, I took my code reader back after getting all the wires hooked up, and again it showed the error codes for the open sensors were still, speed sensors for the back, left and right were still shown, but when this time after a couple, 3 tries, when I asked the code reader to reset the error codes, they did clear. So now I had no error codes in my ABS sensor module. So took the car out for a drive, and on starting the engine I was disappointed that the ABS lights were still on. And when I got out on the road, well, I found that this speedometer did not work. I had high hopes of getting the speedometer working because some of the stuff that I'd come up with on the internet indicated that the left rear speed sensor also provided the signal for the speedometer. So I had hopes that getting that wiring repaired would get my speedometer back in operation. I drove the car a couple, 3 miles, came back and sort of dejectedly pulled up in front of the shop here, trying to decide what my next move would be. And I shut the engine off, went inside, moved a few things around that were in the way so I could get the car back in the shop. And when I got back and started the engine, lo and behold, all the ABS lights went out. I have no idea why. Did I need to cycle the ignition switch a certain number of times? Did I need to drive and clear out a buffer? It's really, truly unknown to me what happened, but made no changes in the wiring, and where I had an error signal, I no longer had the idiot lights on the dash coming up. And when I took the car immediately out for a drive, the speedometer was working. So I guess all's well that ends well. And in this particular case, I used a oscilloscope to try to locate the problem, just because I was getting desperate to try to figure out how or what was happening with my speed sensors. In reality, you really don't need a oscilloscope. You can just hook, if you find yourself in a spot where you think you might have somehow gotten the polarity of the speed sensor reversed, you can always, if you can get to a point where you can hook into the circuit, you can just use a multimeter, and when you turn the ignition switch on, if the voltage stays 0, you've probably got the polarity reversed. If it swings up to, well, on the scope we were seeing 10, maybe 12 volts, something in that range, offset at when it starts. And just to show you here, I'll hook a meter up and turn the ignition on so you can see what happens. Now you are looking again at this would be on the left rear side of the car, and I have a multimeter hooked up here, and you can see the alligator clips where I've clipped into the, just on the extreme left side of the image there, where I've clipped into the circuit going to the speed sensor inside the car. And then, again, this is right at the inside the car, right at the in the front of the rear seat. Now I'll reach into the car, turn the ignition on, and let's see what happens. And now you see that the voltage climbed to, what is that, 9.47 volts. And that is an indication that the speed sensor is forward biased, and that the ABS unit is sending this voltage to the speed sensor. It's a DC voltage that you're looking at. And if you get the speed sensor reversed and you can make that connection, then it'll probably drop to 0 or a few millivolts. And you know darn well that that you've got the units hooked up backward, the unit being the speed sensor hooked up backward. Well, I very much appreciate you taking the time to look at this video. I hope that I hope that this is of use to some of you do-it-yourselfers. I wish I knew what was going on, why the ABS lights didn't clear immediately when they were supposed to, and why it suddenly cleared up. But anyway, so far, I've got my speedometer back, I've got my ABS working, and the world is a happy place. I thank you all for watching, and if some of you experts know what the secrets are on getting these ABS lights to reset like they're supposed to, I would sure like to know. But anyway, I'm happy things are working again. Until next time, goodbye.